Hi, everybody. We're doing P.5, which is evaluate recursive formulas for sequences. It's really scary looking, but they're really pretty simple. So I did preview it, so they're pretty easy to do. I just want you to understand what the notation means. So basically what they're telling you is in this formula right here, let me point at it real quick. This is saying to get to the next number, take the number before and multiply it by 10, because a to the n minus 1 is the number that happened before in the sequence. And to get to the next number, you have to multiply the last number you did by 10. So we're starting at 4. And this is a to the 1. Now to get to a to the 2, it literally says right here, take 10 times a to the 1 to get to a to the 2, because a to the n, and I'm going to make it, I just want to make sure it's perfectly clear what they're doing, a to the n minus 1. This is really scary looking notation, but just keep in mind that if this says a to the 2, then this one just simply says a to the 1. And a to the 2 is 10 times a to the 1. Now, the reason why they write it the way that they do is because if you wanted to know what a to the 10 was, then it would be 10 times a to the 9, wouldn't it? And a to the 9 is the one that came before a to the 10. Now that means that we're multiplying by 10 every time. And in order to get a2, we're going to take 4 times 10, which is 40. And to get to a3, we're going to take the 40, which is the one that came before, and we're going to multiply that by 10, which is 400. So we have 40 and 400. Sometimes they're going to add, sometimes they're going to be geometric series. In this one, it's a geometric series, so we're multiplying by 8. Again, to get to the next one, you multiply the last one by 8. So if a to the 1 is 1, then a to the 2, we multiply the last number by 8 and get 8. And a to the 3, we multiply the last number we had by 8 and we get 64. And so that's it. 8 and 64. Don't get scared of this. This just says to do the next one, multiply the last one by 8. Okay, this one says to get to the next number, add 7 to the last number you did. So to get to, and notice that we're asking for A3, not A2. So A1 is -2. To get to A2, it specifically says take A1 and add 7. So take that and add 7 and you get 5. And to get to A3, you're not going to add this number, you're going to add this number and you're going to add 7, which is going to be 12. So A3 is 12. Not that scary, right? Okay, so this one, we're going to start at 5. A1 is 5. A2 is going to be 5 times that much. We're multiplying every term, last term by 5, so this is 25. And A3, do you know the cube for 5? 5 times 5 times 5 is 125. You're only doing 5 quarters. That's a way to think of it. 125. Here we go. Now we're going to take A1 is 1. Oh, we got to go all the way to 4 this time. And A2 is going to be being multiplied by -3. So we're going to multiply by -3. We're going to get -3. A3 is then +9. And A4 is -27. Sorry, it's a little, I'm multiplying by -3. So I get -27. This is just a geometric series where we're multiplying by -3 each time. Okay, this one we're going to subtract 10. So we want A1 is -2, and then A2 we're going to subtract 10. Be careful, that is -12. And A3 we're going to subtract 10 again, and we get -22. That's it. So in this one, we're multiplying by 9. Each term, take the last term and multiply by 9. This is called recursive. It's not because you're going to curse it all the time or even curse it over and over again, but you're doing it over and over again. That's what's happening. That's why it's called recursive. We're doing the same thing. We're taking the 3, which is A1, and we're multiplying it by 9 in order to get to the next part, which is 27. We multiplied by 9, and that gives us our A2. To get to A3, we have to multiply by 9 again, which is going to be what? 9 times 27? Looks like 263? No, that's not right. 243, sorry. Can't multiply today. If you need to, you can always take the 27 times 9 on up here. It's going to be the 3, carry the 6, and that's going to be 24, so 243. It's going to be my A3. Remember, 243 is 3 to the 5th power, isn't it? Okay, we're going to start with -8. That's A1. And we are going to add 11. So we're adding 11 to A1 to get A2. And that's going to give us 3. And then to get to A3, we're going to add 11, and we're going to get 14. They want to know what is A4, so we have to add 11, and we get 25. We're going to start at 1, and we're going to multiply by -2, which gives us -2. And we're going to multiply by -2, and that's going to be +4. Remember that when you multiply by a negative number in a geometric series, they alternate negative, positive, and so on. Okay, this time we have 1 and 1. Okay, this is actually the definition of the, I'm so slow today. I'm sorry. My brain is not working today. This is called the Fibonacci sequence. And the way it works is that, and it's a very important sequence in nature, you take the last 2 and add them together. So we have 1 and 1, and then the last 2 we add together. This is the last 2 numbers before that. So this is to get to A3, if you want to see it a little bit better. To get to the A3, I have to take a to the n minus 1, which is A2, and a to the n minus 2. Notice that 3 minus 2 is 1, and I have to add these together in order to get to A3. So that's going to be 2. And then in order to get to A4, we have to add the last 2 together, which gives us 3. And to get to A5, we have to add the last 2 together to get 5, and so on. So they want to know, what are these? A3 is 2, and then 3, and then 5. So this time we are going to take, oh, interesting. Okay, so this one is a little different than the others. You have to go 2 back and look at which one happened 2 before. So A1 is -2, A2 is 0, and A3 is going to be 2 times A1. You see that? That's what it's saying, go 2 back and multiply that number by 2. So that's going to give us -4, isn't it? Now, what's going to happen next? A4, we're going to have to look 2 back, and we're going to have to multiply that number by 2, which is going to give us 0. Got it? And looks like we need another one. A5, we got to look 2 back, and we're going to multiply that number by 2, which is going to give us -8. And then to get A6, we're going to have to look 2 back, and we're going to have to multiply that number by 2, and that's going to give us 0. I think you can see what's going to happen. We're alternating zeros and negative values that have, looks like powers of 2. -2, -4, -8. I'm going to guess the next one's going to be -16, which it is, of course, and so on. So it's a nice alternating series. Let's see, we've got -4, or sequence, sorry, 0, -8, and 0. We just have to follow what it says. It tells us what to do in the recursive formula. It tells us what equations we have to follow. Okay, now we have to double both of the previous two numbers and add them together. So this is a doubled and an increasing Fibonacci sequence of some sort. So we've got A1 is 2, A2 is 2. Now to get to A3, and it says right there, take the last one and the one before that and multiply them both by 2 and add them together. So I have to multiply the A1 by 2. I have to multiply the A2 by 2, and then I have to add that together. So 4 and 4 is 8. Now to get to A4, I have to take this one, and I have to multiply them both by 2 and add them together. That's what this thing is saying. Look right here. And it looks really, really confusing if you look at it. But think about it. It says to get to A to N, take the one before and multiply it by 2, take the 1, 2 before and multiply it by 2 and add them together. That's all it says. So to get to A4, you take the 2, which is 2 before, multiply it by 2, take the 8, multiply it by 2, which is 16, and 4 gives you 20. That's all. Not that hard. Now A5, I'm going to take this one, and I'm going to multiply them both by 2 and add them together. That's going to be 40 and 16, which is 56. And to get to A6, I'll bet you know, you're going to take the last two, this one and this one. You're going to double them, which is going to give you the 40 and the 112, and you're going to add them together, and that's going to be 152. That's it. We're all set. We just got to put them in. We've got A3 is 8, and then 20, and then 56, and then I want to double check this one. That looks good. 152. Looks okay. Now we are going to subtract the last number, and then we're going to take away 2 times the number before that. So it's telling you exactly what to do. So let's write them. I'm going to write them down here so I have a little more space. So I've got A1 is 3, and A2 is 4. And A3 specifically says, and I'm going to write it like this, A3 says take A to the n, or the term A n minus 1, which is A2 in this case, isn't it? 3 minus 1 is 2. Minus 2 times n minus 2. Well, the n is 3, so 3 minus 2 is 1. And what I'm going to do is I'm going to take A2, which is 4, and I'm going to take the A1, which is 2 before, and I'm going to multiply it by 2. That's 6, and I'm going to subtract them, and I'm going to get -2. Now, it's very confusing if you think about it too much, but if you just do what it says. To get to A4, I have to take the one that's right before it, -2, and then I have to go 2 before and get the 4, and I have to subtract 2 times that number. And that's going to give me -10. This is -2 minus 8, which is -10. Now to get to A5, I'm going to take the -10, which is the one before, and I'm going to subtract 2 times the one that was 2 before, which is -2. And there's our problem. Look at that. We've got that double negative. A lot of people get very confused because they see a subtraction, they see a negative, they see a multiplier. There's all kinds of things going on. Basically, I see 2 negatives together being multiplied together. And the best way to think of this is really plus a negative. Did you see where I changed that from subtraction to adding a negative? Because when you multiply 2 negatives together, you know you get a positive, and you know how to add, I hope, negative 10 plus 4. The sum of integers, I hope you don't have to grab a calculator for this. The rule is really simple. It is who won. Think about it as a battle between negatives and positives. And negative 10 wins by 6. So that's a negative 6. It always works like that. I know you've probably learned some rule about change the sign and take the sum if the numbers are the same or the signs are the same and blah, 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 blah. No, just who won. That's it. Now we're going to do A6 now. And we're looking at A6. And don't get scared. It's just going to be the negative 6. I'm going to write it right there. And then I'm going to subtract 2 times the negative 10. And again, we've got that darn negative happening, but watch how easy this is. I'm going to change this subtraction that you see right there to adding the opposite. And all of a sudden it becomes very clear. I have negative 6 plus 20. That is a positive 20 because I have a negative times a negative. And who won? Well, the positives win by how much? By 14. And we're all set. Now, some people are going to grab a calculator, and this is going to take them a lot of time. It took me quite a while because I was explaining it, but it really isn't that difficult once you get the hang of it. And of course, it does take practice. That is negative 2. A4 is negative 10. A5 is negative 6. And A6 is 14. Okay, we have a to the n. We're going to add the last one plus 2 times the one before that. So it's very similar to the last one we did, except this time instead of doubling it and subtracting, we're going to double it and add it together. So we're going to take 2 before, we're going to multiply it by 2. We're going to take the last one and add it. So we have A1, and I'm going to go a little faster this time. That 5 is 5. Oh man, come on now, stop that. There we go. I don't know how to get rid of that thing. Let me stop. There we go. Just had to double tap or something. A2 is going to be 1. And to get to A3, we just look at what it says. Take the last one, which is 1. This is the A2. For A3, I have to take A to the 3 minus 1, which is A2. And I'm going to add 2 times n minus 2. Well, n is 3, so it's A1. All right, now I'm going to go a little faster. So the last one is 1 plus 2 times 5, because A1 is 5, and that's going to be 11. Now to get to A4, I'm going to take this one, and I'm going to add twice as much as that. 2 and 11 makes 13. That's all. A5, I'm going to take this one, and I'm going to double this one. That's going to give me 22 plus the 13 gives me 35, doesn't it? And A6 is going to be my 35 plus 2 times the 13, which is 26, and that's going to be 61. That's all. Now, there's reasons why you want to have a recursive formula, because sometimes what happens later depends on what's happening now. For example, if you're talking about supply lines and things, the amount of supplies that you have will determine, and a lot of times the supplies that are coming in from last week are going to determine how many supplies you need for this week, and so on. Anyway, recursive formulas are important, and they're one of the ways to model the real world in math. All right, so we've got, let me get rid of this stupid thing. I don't know why. Let's keep popping up. All right, we got A3 is 11. A4 is 13. Sorry about the little dots there. I guess it won't bother you too much. 35 for A5, and A6 is 61. I don't think I made any sign errors or anything. Looks good. All right, let's see what the next one says. Oh, a little more interesting. We have to multiply by a fraction. Don't be afraid, it's just a fraction. But here's where you get into problems with your calculator. For those of you who don't know, 2/3 is 0.666666666, repeating forever. And there is no way to get the exact answer with your calculator. What you will get is an approximate answer, but it is so much easier to just deal with the fraction. So I have A1 and A2. This is what this says. A2 is 2/3 of the last one, which was A1. So 2/3 of 36. Do you know how much that is? Well, think about it like this. Split it up into 3 equal pieces. That's 12 and 12 and 12. And 2/3 of that is 24. To get a picture of it, I want you to think about what multiplication really means and what division really means. You see, when you see this 3 right here, it says divided into 3 equal parts. Well, that's 12 plus 12 plus 12. And the top part tells you how many of those parts you get. Sorry. There it is, 24. The reason I like to teach it this way is that when we get to fractional exponents, it will make a lot more sense to you if you understand fractions in this way. Anyway, 2/3. Now for A3, I want 2/3 of 24. Well, 24 divides up into 8 plus 8 plus 8, doesn't it? And I want 2/3 of that, so it's 16. Now I know some of you learn to cancel and multiply and so on. The problem with it is that you don't get a fundamental sense of what's really happening when you do this, when you take the 16 times the 2/3. Of course, it's pretty hard to divide 16 into 3 equal pieces. So we really don't have a lot of choices here. It says that we want the fractions in simplest form. So we are going to keep the fraction. And this is going to be 16/1, which is 32/3. So that's going to be A4. The bad news is 32/3. 32 is a power of 2. So it's 2 times 2 times 2 times 2, 5 times. And there's no simplifying this. A5, we're just going to multiply the A4 times 2/3, which is going to give us 64/9, isn't it? So we're multiplying up powers of 2 and powers of 3. And it looks like we've got them all. We've got 36, 24, 32/3, and 64/9. We're just, this is called a decay. It's, well, not exactly, but it's going down 2/3 as big each time. It's a geometric decay. And it's going to get smaller and smaller and smaller. It's never going to quite get to 0 because 2/3 of something is always something, if you think about it. It's going to get smaller and smaller, though. What? What did I do? What? 24, 16. Did I put 36? What did I put? Did I not put my answers in? 32/3. What? 64/9. 24. Oh my God, I put 24 for the second one. And I put 36 for the first one. I'm an idiot. Sorry, guys. I gotta quit talking so much and actually do the problems. What I did was I answered the original instead of the 2/3. Oops. So, dang. I couldn't figure out what I did wrong. All right. Well, here it is. This time it's kind of interesting. We're going to multiply the last one by -2 and the one 2 before by 2, and then we're going to add them together. So we have 5, A2 is 5, A3, we're going to take this one and multiply it by -2. We're going to take this one and we're going to multiply it by +2. And we're going to add them together and get 0. Now, to get the A4, we're going to take this one and we're going to multiply it by -2. And we're going to take this one, we're going to multiply it by +2. So we're going to take 10 and 0 and get 10. And to get to A5, we're going to take this one and we're going to multiply it by -2. We're going to take this one and multiply it by +2, and we're still going to get 0, and we're going to get -20. Let me get rid of that for a second. And to get to a to the 6th, we're almost done. We're going to take the last one and multiply it by -2, which gives us the 40. And we're going to take this one and multiply by +2, which gives us the 20. And when we add those together, we get our 60. So it looks like we have 0, 10, -20, and 60. Assuming I didn't do anything silly like I did last time. All right. This time we're going to double the last one and add the one before that. So A1 is 4. I'm going to put it down here. A2 is 1. And A3, we're going to double this one times 2, and we're going to add that one. So we've got 2 plus 4 is 6. And to get to A4, we're going to double this one. That gives us 12 plus the 1. Remember, we're not adding the double this time. It's 12 plus 1 is 13. And to get to A5, we're going to take the last one and we're going to double it. That's 26 plus the 6. So 26 plus 6 is 32. And to get to A6, we're almost there. We're going to double the 36, which gives us the 64, plus the 13, which gives us 77. And I think that's all of them. So we have 6, 13, 32, and 64 and 13 is 77, I think. I don't think I made a mistake. Oh. I hate it when I make errors. Okay, so this one, we're going to double the one before and multiply by -2. We're going to change the sign of the one before that, and then we're going to add them together. So there's a lot of stuff going on. We're going to multiply the last term by -2 and the second to last term by -1, and then we're going to add them together, and then we're going to get our new term. So we have A1, don't let it freak you out, that's 3. A2 is 2. And to get to the next one, we're going to take the last term and we're going to multiply it by -2. That's going to give us our -4. And then we're going to take the term before that. We're going to multiply it by -1. We're going to get the -3. And then we're going to add those together and get -7. Now, I know you're thinking, well, there's a subtraction there. Why are you adding? Well, it's easier to add negatives than it is to subtract from negatives. Subtraction is a big problem in mathematics. Anyway, A4, we are going to multiply the last term by -2, and that's going to give us our 14. And then we're going to multiply this one by -1. We're going to change the sign, and then we're going to add them together and get our 12. Got it? A5, we're going to multiply the last term by -2. Forget this. And that's going to give us our -24. And then we're going to change the sign and add it to -24. Now, this can get really confusing. I'm talking about -24 minus -7, which is really +7. And the question is, who won? And the negatives win by 17, don't they? And I need one more, A6, which means I'm going to multiply the -17 by -2, which is going to give me 34. I'm going to change the sign on the 12, and I'm going to add them together. So I'm going to add the -12 plus the 34, which is 22. So there's my sequence, -7, 12. I know this looks really confusing, but if you do it yourself, instead of just watching me, I think you're going to find that it isn't as hard as it looks. Maybe try to do it ahead a little bit. Take a look, pause my part, and maybe let me get started and then try and finish it up. And I promise to follow the leader is a very effective strategy, at least to begin with. Now, the best thing you can possibly do for yourself is to teach someone else how to do it. That's going to advance your level 100 times better than just watching. All right, let's see what we got here. Okay, this time we're going to multiply by 2/5. Let's see if I can do it right this time. I'm so sorry I messed that up. So A1 is 45, and we're going to take 2/5 of 45 to get to the A2. So we're going to multiply it by 2/5, which is going to be 18. If you want to see it, I'll write it down at the bottom. 45 times 2/5. This is over 1, and the 5's cancel if you like. What I'm really doing is I'm dividing 5 into 45, and I'm getting 9. And 5 into 5 is 1. That's a way of thinking about it. And 9 times 2, of course, is 18. Now, I'm going to take the 18, and I'm going to multiply that by 2/5. And that's going to give me 36 over 5 to get my A3. And then I'm done. That's it. Does not look like what your answer would be, but that is correct, I think. I'm not trusting myself on those for a minute. All right, this time we're going to take 3/4. Looks like my AI is kicking in, and it's going to make sure I really do know what I'm doing. A1 is -44, and to get to A2, it says take the last one you did and multiply it by 3/4. So you're going to take -44 and multiply it by 3/4. And I hope you can try this yourself. You're just going to simplify the 4. 4 is going to go into -44, -11 times, and that's going to give us our -33, isn't it? Darn, that's irritating. There we go. Hopefully that doesn't show up. I don't know if it does or not. All right, so A3 is going to be -33 over 1, but I'm going to multiply that by 3/4. Now for the bad news, 4 does not go into -33 evenly. It goes in -8.25. Now I could multiply that by 3, and I would get an answer, -24.75. But you just want to use the fraction. It's -99 over 4. It's fine. Don't freak out. The next one, I'm just multiplying the numerators and the denominators. There's no simplifying this. 4 is just 2 times 2, and there's no 2's that are going to go into 33 or 3. Now A4, we're going to multiply the -99 over 4 by 3 over 4, because they told us to do that. -99 times 3 is -297, isn't it? It's almost 300. That's how I did that, by the way, over 16. And I already know there's no simplifying, because 99 is 3 times 11, and there's only 3's and 11's in the numerators, and there's only 2's in the denominators. This is your answer. Okay? Negative. That's A4, yeah. 297 over 16. Oh, not negative. I think I got it. I think it's 297 over 16. I hope I put the negative in there. I think I did. Of course I did. All right. This time we're multiplying by -1/3, and they want quite a few of the different terms, so it's not that bad. A1 is 36. The good news is 36 is a nice number. We're going to be able to do 2 of them before we run out of before we start getting into fractions. So I'm going to take the 36 and I'm going to multiply it by -1/3, which of course is -12, however you want to think of it. Notice we're going to be alternating positives and negatives because we're multiplying by a -1/3. 3 goes into 36 12 times if you need to see that. Now I'm going to take the -12 and I'm going to multiply that by -1/3 to get the next term, which is going to give me 4. If you like, one way to do this is just multiply these. That's 12 over 3, because it's a negative times a negative, and that's going to give you 4. Of course, I find it easier to do this. The only problem is some people are going to write the 4 and get a negative out of it, which is going to be wrong. You don't want to forget your negative is there. Anyway, it is 4. A3 is 4. Now it gets a little more difficult because we're going to take -1/3 and multiply it by 4. Oh, it's supposed to be 4. I want to get rid of that. I don't want to have a negative on there. There we go. -4 over 3, isn't it? if I multiply 4 by negative 1/3, I'm going to get rid of the equal sign. That is negative 4 over 3. Now I have one last one, A5, and I'm going to multiply by negative 1/3. Well, I know you can do this in your head. You're going to multiply the negative 1 times the 4 and get positive 4, and 3 times 3 is 9. Notice that it's alternating and it's going down in value. It's 1/3 and 1/3 and 1/3. We're never going to quite get to 0, but we're going to alternate. And what this, the graph of this thing, if you were to look at it, we would start at A1, which is 36, and then it would come down to 12. This is kind of an oscillating kind of thing where it gets closer and closer and closer and closer, but it never quite gets there. See how it's alternating? This is modeling things that are oscillating, things like springs that move up and down, things like that. Anyway, very useful in physics. These kinds of formulas, that's going to be negative 12. We have a 4. Oh, next one. You know what? I think I'm going to get rid of these and stop writing on it. Okay, we've got negative 12 is A2. 4 is A3. Then we have negative 4/3. Now, if I were doing this myself, I wouldn't have written any of this. I would have just done it in my head. I could see that I'd multiply by negative 1/3, and I'd be able to multiply in my head. Probably some of you can too, with a little bit of practice. And that's going to be positive 4 over 9, isn't it? And you're just multiplying by negative 1/3 each time. Or think of it as dividing by 3 each time and changing the sign. Either way, whichever makes more sense to you. All right, this time we're going to take a half. Now this is truly a half-life. This is what happens when isotopes decay over time. You get half as much again. Now the scary part is that there are half-lives that occur in fractions of seconds for really unstable isotopes. But for more stable ones, the radioactivity can last for 500 years, 10,000 years. The half-lives are pretty amazing. Now, what's really strange about it is that because you're constantly taking half, you never quite get rid of all of it. And the decay looks something like this. If we start at 92, if you want to see a picture of it, darn, let's get it. There we go. So we're starting at 92. And of course, after one half-life, whatever it is, if it's 1 year, if it's a millisecond, whatever it is, we're at 46. And then the next time we're half of that, which is 23. And then the next time we're half of that, which is going to be 11.5. And then half of that, which is going to be what, 5.75. And so on. It's going to get closer and closer. This is called decay. And it's a half-life decay. It's going to get closer and closer and closer to 0. It's never going to quite get there. So we want A4, which is, I'm going to go ahead and write them. That's 92. And then A2 is going to be half as much, which is going to be 46. And A3 is going to be half as much, which is 23. And A4 is going to be half as much, which is 11.5. Oh, it says fraction. Okay, 23 over 2. Same thing. Okay, we're getting there, guys. Keep it up. Hopefully you don't mind me giving you extra. Okay, so we're going to A5. We're starting out at A1 at 54. And A2 is going to be 1/6 of that. So we're going to divide that by 6. That's going to give us 9. Now A3 is going to be 9 over 6. Now that can be reduced. So I'm just going to go ahead and reduce it down here. We're multiplying by 1/6, however you want to think of that. And we're going to divide by 3. It's going to give us 3 over 2. And now I'm going to multiply by 1/6 again. I'm going to go ahead and multiply it so you can see it. The 6 simplifies with the 3 to give us 1/2 times 1/2. It's 1/4. So A4 is 1/4. I want you to notice that it's going down fairly quickly. We're getting smaller and smaller and smaller. This is, and it's happening pretty quickly. Now I'm going to multiply by 1/6, and hopefully you can do that in your head. That's 1 over 24. And looks like we have them. And that's the one that we're interested in. Okay, 90, and this time we're multiplying by negative 1/6. It's very similar. So we have A1 is 90. We're going to multiply A2 by negative 1/6, and I'm going to go ahead and put it down here so you can see it, so you don't get confused. 6 does go into 90 15 times, doesn't it? And that's going to be negative 15. And then we're going to multiply the negative 15, notice no equal sign, over 1 times negative 1 over 6. That's going to be a positive. The 6 is going to get, 3 goes into 6 2 times, and 3 goes into negative 15, negative 5. Be careful, don't lose your negative. That's going to be 5 over 2 for A3. And again, it's going down quite fast, but it's alternating between negatives and positives. So A4 is the one we want. And we're just going to take the 5/2 and multiply it by negative 1/6. There's no simplifying. It's just going to be negative 5 over 12. And I'm getting a little tired, so looks like it looks like this is going to take us a while. It's my own fault. I made that silly error early on. All right, so we start with 5. A1 is 5, and we're going to multiply by negative 1/5. A2 then, if we multiply by negative 1/5, we get negative 1. And then we get positive 1/5. And A4, then we get negative 1 over 25. And then A5, I'm just multiplying by negative 1 over 5, okay, guys? That's all I'm doing. And A5 is going to be 1 over 125. And that is it, isn't it? What is that, 0.08, I think? Or no, 0.008. Pretty small. Anyway, A5 is 1 over 125. And it is positive. We got to be careful. Alternate those negatives and positives back and forth. All right. Oh, again, with this weird multiplying the one before by 2 and the 2 back by negative 2. There we go. I've got A1 is 1, A2 is 4, and A3, we're going to take the one before and multiply it by 2, multiply this one by negative 2, and we're going to get negative 2 and 8, and we're going to add them together. We're going to get 6, and I'm going to get rid of this. It just makes it easier that way if I'm kind of restarting each time. We want A4. We're going to take the last one and multiply it by 2. We're going to take the one before that and multiply it by negative 2. And we're going to get negative 8 plus the 12, and we're going to get 4. And then I'm going to get A5. Sorry, that doesn't look like an A. There we go, A5. We're going to take the last one and multiply it by 2. We're going to take the one before that and multiply it by negative 2. We're going to have 8 and negative 12, and we're going to get negative 4. And I think I didn't. I'm pretty sure it's right. All righty then. I'm going a little fast, I know. I'm sorry. I just want to get done. All right, so we have A1 is negative 5. And A2 is positive 5. And we have to change the signs of the last two numbers and add them together. So we're going to take this one and change its sign. See, that's what it says. That's where that says. Take the second to the last one and change its sign, and the last one and change its sign, and then add them together. So 5 plus negative 5, I change the signs, and I still get 0. Now, even if I had not changed the signs, I would still get the same thing. But now I have to be careful. So now I got to make sure I change the signs and add them together. So change the signs and add, you get negative 5. Now A5, we have to change the signs and add, which is going to give us positive 5. And there it is. Now this time we want to multiply 2 back. We're going 2 back. See, we're going the one the second one before last. Gotta be careful not to submit yet. I've got A1 is 3. I've got A2, which is -1, and A3. It is important to get them all. You'll see why in a second. I'm going to multiply this one by 3, and I'm going to get 9. Now for A4, I have to multiply this one by 3, and I get -3. And to get A5, I have to multiply this one by 3, and I get 27. And to get A6, I have to multiply this one by 3, and I get -9. There it is. It is really easy to make mistakes on these. You just have to be careful and follow directions. All right, so A1 is 0 and A2 is 1, and we're going to subtract them out of order. In other words, I'm going to take the 1, this last one, and subtract this one from it. So I'm going to switch them 1 minus 0 and subtract them. That's going to give me my third term, which is going to be 1. Now A4, even if I switch them, I still have 1 and 1, but I'm supposed to switch them and take this one minus this one minus this one. So it's 1 minus 1, which is 0. And A5, I'm going to switch them again. I'm going to take 0 minus 1. I'm going to get -1. And for A6, again, I'm going to switch them and get -1 minus 0, which is -1. So we have A3 is 1, A4 is 0, A5 is -1, and A6 is -1. Looks good. Okay, so A1 is 0, and A2 is -4, and we are going to, oh, it's just equal to the 1, 2 before. So A3 is 0, and A4 is -4. See, I'm just going 2 back. And A5 is 0, and A6 is -4. There it is. Some people would probably get freaked out by that because you didn't have to do anything. All right, this one we're going to multiply by -3/5. And, oh man, I want quite a few. Okay, so A1, there is a way of skipping all the steps, but I don't think it's a good idea. Not yet anyway. Later on we'll have to because we're going to be dealing with the formulas. But 95 times -3/5, and the 5 cancels the 95 to give you 19. When you multiply that, you get -57. That's going to be A2. And then A3 is going to be -57 times -3/5. And there's no simplifying this one. It's going to be, what, 171 +/5? Yuck. A4 is going to be multiplied by -3/5. Man, I might want a calculator for this. 171/5, and we're going to multiply by -3/5. And we're going to get -5. Oh man, yeah, -513, I think, over 25. And there's no simplifying it. I'm going to go ahead and multiply it up above, but I'm pretty sure it's right. 171 times 3. It's going to be 3, 1, carry the 2. Of course, it's 513. And we do have a negative because it is negative. Now, I still have a couple more to go. -513 over 25, and I'm going to multiply that by -3/5. Again, there's no simplifying it. It's going to be -1539. Oh, positive, sorry. 1539 over 125. And then we're going to multiply that by -3/5. And at this point, I know the denominator is 625. The numerator is going to be -46, what? It's going to be 27 and 17. Okay, so I'm going to go ahead and use the calculator to check it. I'm sure it's right, but still I'm going to do it. So we have 513 times 3 is 1539 times 3 is 4617. Yep. And it is going to be negative 4617. Let's make sure. A4 is negative 513 over 25. And there's A5, which is that one. And so this one right here is A6. Now, of course, I could just multiply by negative 3/5, however many times I needed to do it. And that is a power, isn't it? So there's ways of writing this, and we're going to write geometric formulas in another one. It's called an implicit formula instead of a recursive formula. But anyway, there it is. Negative 4617 over 625. Looks good. And we're on our last one. I'll be careful on this one. Well, at least I'll try to be. We have A1 is 3 and A2 is 5. I can't imagine anybody still watching, so. All right, we're going to take the last one and multiply by negative 2. And we're going to take the one before that and just add it. So we have 3 plus negative 10. Sorry, it's 3, there we go, plus negative 10, which is negative 7. Now for A4, I'm going to take the last one and multiply it by negative 2. Let me get rid of this. And that's going to give me my 14. And I'm going to add it to the 5 to give me my 19. Let me get rid of that. I'm going to go to A5. And I want to take the last one and multiply it by negative 2, which gives me negative 38. And I want to add my negative 7 to that. And I'm going to get negative 45, aren't I? Oh my God, that's irritating. I've got, hopefully you guys aren't, I don't know if you guys can see that or not, but every day I get Zoom meetings that I have to go to, and they come up whether I want them to or not. This is Sunday, so not a good thing. Anyway, negative 38 plus negative 7 is negative 45. And we have one more. A6, we're going to multiply the last one by negative 2, which is going to be 90. And then we're going to add the 19, which is going to be 109. Okay, it looks good. Hopefully I didn't make any dumb errors. Negative 7, 19, negative 45, and 109. Whenever I get distracted, sometimes I always worry that it's going to mess me up, but I'm pretty sure it's right. So do yours, go to your 100, get your mastery, and I'll see you again sometime. Bye-bye.